Hello, today we're going to look at some examples of graphing lines. Okay, so my preferred method of graphing lines would be that my equation is in slope-intercept form. And I hope you remember slope-intercept form is y equals mx plus b. And I like this form because I feel like it tells me everything that I need. And when I graph lines, I feel like I just need 2 to 3 points to help me. So let's start here with my y-intercept. The y-intercept, as you know, is the place where my graph crosses my y-axis. Here's my y-axis. It tells me right here, plain as day, that my y-intercept is at -2. So I'm going to put a mark here at -2. Then my slope tells me how much to rise up and run over. And it also lets me know I'm going in a positive direction. So I'm going to rise up 7. So that's 1, 2, 3, 4, 5, 6, 7. And I'm going to go over 2. 1, 2. So here's my next point. So for this graph, because I don't have that much space, I'm going to stick with just 2 points. Let's see if I can get a line here. And so my line is going to be something like forgive me for it not being perfect, but hopefully you know, just connecting those 2 points is my line, and it goes in both directions forever and ever. All right, let's do the next one. So again, my y-intercept, or the place where it crosses the y-axis, is at 3. This time I can see that my slope is negative. It's going down the hill. So I'm going to count down instead. And then my slope is -6. If you recall, I do like to keep it in fraction form because it helps me to know what my rise and my run are. So this is -6, and we all know that it's -6 over 1, right? So there's that invisible 1 there. So I'm going to go down 6. That's 1, 2, 3, 4, 5, 6. And I am going to go over 1. Okay, and so it's over 1 here. And as you can see again, I'm probably only going to be able to do 2 points. I would prefer 3, but I can only do 2. So I'm going to put a line between. Oh, and I can't. This line is not. Let's see. It's a very, very steep line, right? Because I have -6. Maybe not like that. So as you can see, this is my line. Let me deal with my actual. So let's look at something like. And as you can see, it's going down the hill. It's negative slope. So this is that graph. All right, the next one, we have y equals -5. If you recall, when I have it in something like this, this is my y-intercept of -5. And so it is just a horizontal line this way, -5. Remember Buck's Hoy? Where B is vertical line, undefined slope, x equals, H is horizontal line, 0 slope, and y equals. So this is y equals horizontal line, and my slope is 0. Okay, next we have a x equals. So now this is my x-intercept. So my x is 5 right here. So this is my line. And I haven't been putting my arrows on there, but I hope you know it goes on and on. Forever and ever. It's a line. That's the definition of a line. And it is a vertical line. All right, next we have y equals 5/3 x plus nothing. So that means that my y-intercept is 0. So that's going to be my first point right here, 0. Then again, I'm going to use my slope. I'm going to go up 5. 1, 2, 3, 4, 5. And I'm going to go over 3. 1, 2, 3. And let's go down 5 this time. 1, 2, 3, 4, 5, and over 3. 1, 2, 3. All right, so let's see if I can connect my line. It kind of connected. But I hope you understand the point. I'm just trying to connect those 3 points. All right, now what if it is not in slope-intercept form? One, I can put it in slope-intercept form, or I can just use my intercepts. So if I use my intercepts, that means that I am saying, let's say if I want to use my y-intercept, so y-intercept is it's the place where my graph crosses the y-axis. And so if it's the place where the graph crosses the y-axis, that means my x is 0. So when my x is 0, bam, bam, is 0, my y equals 5. So my y equals 5 is right here. All right, well, what about, let's get rid of this. The x-intercept, similar to the y-intercept, instead of crossing the y-axis, what axis do you think it crosses this time? You guessed it, it crosses the x-axis. And so that means that my y is 0 this time. I get 7x equals 5. So I need to find out what that is. So 7x equals 5. So that means x is equal to 5 over 7. So it crosses at 5 over 7, which is really, really small. Not really, really small, but it's less than 1. So there's a point right here. Okay, so if I try my best to connect those points, what would you say that slope is doing? Looks like it's negative. We can actually solve it to see, not solve it, but we can put it in slope-intercept form. So if we do that, we subtract 7x from both sides, and I get y equals negative 7x plus 5. And lo and behold, my slope is negative, so our graph is correct. My y-intercept is 5, our graph is correct. And that is just another way of graphing. Okay, again, I have another standard form, so I'm going to do my intercepts again. So first, I will cross out my x. So when I cross out my x, finding y, so I get 5y. This is my y-intercept, equals negative 5. Divide by 5 on both sides. And it is a y-intercept at negative 1. So I'm going to put a mark here at negative 1. All right, the next one, I'm going to get rid of my y this time because I want my x-intercept. So I get 3x equals negative 5. And I divide by 3 on both sides. And I get x is equal to negative 5/3. And so that is right here. Oh, actually, no, I'm sorry. 5/3 is actually greater than 1. So it's a little bit more right here instead. And it's negative. Not right here. I don't know why. I'm sorry. And so the line looks something like that. It's going down the hill. I can go ahead and put it in y-intercept form. Why don't you try that on your own and send me a message if you feel like my graph isn't correct. All right, let's do this last one here. So we have 6x plus 5y equals 20. Again, I'm going to start off by finding my y-intercept. So I have 5y equals 20. So when I divide by 5 on both sides, I get y equals 4. So I'm going to go here to y equals 4. Put a mark there. The next one, I have 6x plus 5y. This is the same equation. I'm writing it over. I hope you understand that. I am going to get rid of my y, looking for my x-intercept. So divide by 6 on both sides. And I get x is equal to 20 over 6. If I reduce that, that's 10 over 3. And it's around 3. So it's right here. And I can graph that. Should be a straight line, but I am using my finger, so I apologize. So let's go ahead and change this one though to slope-intercept form. So I have 6x plus 5y equals 20, and I'm solving for y. So I'm going to subtract 6x from both sides. And I get 5y is equal to negative 6x plus 20. Divide both sides by 5. I'm going to divide everything over here by 5, of course. I could put one line, or that's the same thing. Everything has to be divided by 5. So I have y equals negative 6/5 x plus 4. And this is exactly what we have. We have negative slope at 4, and it's going down the hill, going down 1, 2, 3, 4, 5, 6 over 5. 1, 2, 3, 4, 5. This is a better mark here. And so these are the points that it connect. And I hope that this helps.